Patrick Cook here. Welcome to session 6 of the Mandelbulb3D Epic Rendering tutorial series, where we talk about how to leverage the Mandelbulb3D application to get us high resolution image files that we can then do things with, such as printing and some other interesting creative things that we'll talk about as we go along. But I wanted to talk about in this session, I wanted to talk about why we have limitations in terms of producing high resolution files. And there really is, there's two limitations that we're faced with. First of all, and usually what will hit you is memory or memory allocation. All right. The second one is the fact that the Mandelbulb3D software is a 32-bit Windows application. Two reasons there. Now let's talk about each one of those independently. The memory or RAM is utilized in a personal computer environment. Memory is what is used to store bits and bytes, store information, hold on to the values of variables, hold information as loops occur, all right, or hold numbers that another chunk of software will refer to, all right. Let me do this. I'll start this for you. I'm going to start this calculation here, all right, and as we talk along. Now, as this particular image is rendering, it's accumulating bytes of data that it is storing in memory, in the computer's memory. And in order for it to be able to continue on to the next process or the next line here, it has to remember the previous line or section that it had already rendered in order to build the image file. And when it's all done, now what it's doing right now is it's calculating the ambient shadows. When it's all done, it has to take all of that stuff in memory and write it out to a file. The Mandelbulb application does not build a physical file as it renders. It builds all of this in RAM, memory. Now, there's only so much memory that the Windows operating system will allocate to an application. And that really depends upon the scale of the application. When I say scale, I'm referring to a 32-bit or 64-bit. In a 32-bit application, it only has 4 bytes of an address that it can utilize. 4 bytes. Okay, a byte is 8 bits. 4. A 64-bit, a 64-byte application would have 16 address bytes. So the point is that it can actually, a 32-bit can only access half the memory of a 64-bit application. So that is an automatic limitation in a 32-bit. It cannot access, it can only access half of the memory of a 64-bit application. The Mandelbulb3D application is a 32-bit application. And that was perfectly fine back in the, 2010, 12, 13 era. And I guess back then we were at Windows, maybe Windows Millennium, maybe Vista. I think that was the Vista era. All right. And 32-bit applications were common and predominant. Over time, the Windows operating system would allow a higher amount of memory access, and PCs could actually have more RAM installed. All right. But, and then they went to 64-bit applications, which are dominant nowadays in terms of new applications, which allowed the application to access more memory. More memory means that bigger stuff can be done by the application because it has more memory to work with. If the Mandelbulb3D application were a 64-bit application, we would have less limitations on the memory. But it's a 32-bit, it's not likely to ever change. That's just the way it is. So you have a memory limitation that is in one way or another related to being a 32-bit. It's also an operating system issue. Just because you're a big old 64-bit application does not mean that Windows is going to allocate all the memory it wants. Windows is a limitation. Windows is an environment, it's an operating system environment that regulates the behavior and the access and the resources that are allocated to the various applications that are running. And there are many applications that are running in Windows. Just because you fire up a browser, there are still probably 2 or 3 dozen applications that are running that you just don't see. They don't have an interface. Now, all right, so the Mandelbulb application has memory limitations. Let me prove that to you. Let's say that I wanted, we know that a 9,000 by 6,000 resolution image, we know that that will render. What if I was to put in 15,000 and I don't know, probably 9,000, I'm just picking numbers. I wonder if that will render. 15,000 by 9,000. That'll probably get us like a 40-inch print. All right, let's try it. Calculate, there we go. So out of memory, decrease the image size. So this is a small example of how the Mandelbulb application there comes a point where the Mandelbulb application won't be able to render on the main screen here because it can't get enough memory. It says out of memory, and what that's really saying is that the application can't get enough memory allocated from Windows in order for it to run, render, okay? So it's a no-go situation. So you have a limit. Let's put a 12,000 in there by, I don't know, 7,000. Okay, let's see if that will render. That's out of memory too. All right, so it can't do a 12,000. Let's put a 10,000 in there by 6,200. Let's see if that will render. Now that won't render either. Let's go back to our 9,000 by 6,000, and that will render. So your effective limitation, if you wanted a print at 30 by 20, that is your effective limitation. Somewhere around 9,000 to 6,000, and this is on my PC. All right, I have an Intel i9 with 64 gigabytes of RAM. This 32-bit application simply can't get enough memory allocated to it in order for it to do much more than 9,000 by 6,000, which would be a 30-inch by 20-inch print at 300 dots per inch. That's still a very respectable print, all right, and that fills up your wall pretty quick. But in this session, I wanted to illustrate the limitation, and that out-of-memory limitation was because this 32-bit Windows application cannot get enough memory allocated to it from the Windows operating system. This is Windows 10. In order for it to compile that entire render, which is all done in memory, and then written out to a file. Okay? So I hope this session has impressed upon you that you have a limitation. You may not ever run into this limitation, and you may be perfectly fine to stay within the limitation for your artistic endeavors. But it's like anything else. If you know that you have the tools and you know how to use the tools, your art is less bounded by the limitations. And that's what we're here to do, is to talk about how to get around this limitation with the Mandelbulb fractal generator. Okay? All right, I'll see you in the next session. We'll continue this fun. I'll see you there.